cable tapped from. So we are going to deselect all, then click on 11 kV, then click on OK. So you might want to select this. You deselect all. Is it single core or 3 core? So in this case, we want 3 core cable. So you deselect 1 core, then select the 3 core, then you click on OK. You can see that the whole thing is getting reduced. Now it is an XLPE cable according to the single line diagram. So you deselect all, then select XLPE cable, then you click on OK. I think this should do us this should be okay for modeling. So these ones are just they are not actually important anyway. So the size of cable that we selected is 500 mm. Let's see if 500 mm is available. Oh, we do not have up to 500 mm. So let's select 400. Let me see, metric. Let's select 400 mm, which is the maximum. So you click on OK. So we've modeled our cable. So we have XLPE, the frequency is 50 Hz, the rated kV is 11 kV, the type of core is 3 core, and we have copper, then the size is 400 mm. So you click on OK. So we've modeled our XLPE cable. So let's try to model these cables as well, which is the upriser cable in this case. So what have we selected? Okay, I think we've selected 240 mm. Okay, let's try to model this cable 3. So just like we've done in the previous cable modeling. So you select, let's say this one is 7 meter. So you select library. Remember that just like we've done copper 11 kV, accuracy class percentage kind of 3 core. We are using 3 core. Then the insulation type is SFP. So and our size of cable is 240 mm. So you click on OK, then OK. So to save our time, so we just copy this cable that we have modeled, then paste. So let's try to join this cable to the bus. So connect the second cable to this bus. That's just one of the way to work smart. So we are just trying to save the work that we've done. So if you double click on this cable now, you will see that the cable has been copied. We now have 240 mm. So for the third cable, you see the same thing. So we've modeled these cables. Now, all right. So what we have left is this load. We have to modify this load as well. The first load is 7 megawatt, 5 megawatt. The second one is 5 megawatt. The third one is 4 megawatt. So the lump load, which is the load 1, so it has been connected already, so it will automatically tap from it will automatically tap the voltage from the bus. So you go to nameplate. Okay, still the same thing with this one. If the type, what type of connection is it? Is it in service or out service? So of course it is in service. It is in service. So the connection, is it 3-phase or single phase? So the reference kV, is it calculator or inside the line? So we use calculated. So you now go to nameplate. What is the rating of the, what is the MVA rating of the load, which is 7 megawatts? So you input 7 megawatts. So if you click on tab, it will automatically generate the other parameters, which is the MVA, the M bar, which is the reactive power, the power factor, and then the amps. Like 7 megawatt equate 367.4 amps. If, well, does it really matter, Sha? But what I'm trying to say is what I would like to chip in is, the power factor is a ratio of the, the active and the apparent and the real power. So go and do the findings yourself. But if you want to change this power factor, so let's say the maximum power factor for one of the distribution company in Nigeria, the maximum they've ever experienced is 0.9. So you input 0.9, then this system will automatically change the 99%. Okay, 90%. So the megawatts will be at 6.3. The MVAR will be 3.0. So in this, and what fact can we actually deduct from this? Power factor is a problem in electrical engineering, especially in power system. So if you want to improve your power factor, it means you like a low power factor, to be precise. If you want to improve power factor, you have to reduce your reactive power. So let's say this is our reactive power is 3 MVA. So at 90%. So our power factor will be at 90%. So let's try to reduce it to 1. Let's put 1 and see the effect. So if you click on your tab, it has improved it from 90 to 98.64. So let's push through so that so let us maintain this 95.09 power factor. So load type, what does this actually means? This refers to the type of load that you have in your system. The type of load we selected is a lumped load, which means you can actually have different type of load on it. You can have the active power, active load, reactive load, and the, what was the third one? I've forgotten. So this aspect of load type actually gives you the opportunity to manage the type of load that you have. So in this case, the system has selected 80% kVA and 20% Z. Then you click, I think we should be okay like this. So you click on OK. So it automatically gives us 6.265 MVA if our power factor is to operate at 0.95, which is 95 point something percent, as the case may be, as we have it on our in our circuit. So you try to modify the second load. So it's still the same thing like the first one. So the second one is 5 megawatts. So let's input 5 megawatts, then it will automatically generate the power factor and everything that we need. So you click on OK. So we should execute. Fine. Okay, what's the 4? We have 4. Click on OK. So to automatically click on OK. Before I forget, I do not think we worked on this breaker, the high voltage breaker, and let's try to see if we can actually select the rating for this breaker. You can see the rating of this breaker is 1.01 kV, and the system we are operating on is 33 kV. So our modeling is not okay per se. So in this case now you select on the rated kV so that you will not overload or spoil the equipment that you are using. So you select the rated voltage. Our rated voltage is 33, but we do not have options to select 33 kV here, so we have 36. So we use the next maximum value. So we select 36 kV. Then the rated amps. What's the rated amps of at the primary side is 262. So let's select 400 amps. So what other things do we need to select? Okay, let's select 1250 amps. Let's select 1250 amps. So I think we should be okay like that, such that you can still use on the 400. Let's use 400 amps. So let's click on OK. So we've modified the circuit breaker 1. So let's go to circuit breaker 2. Double click on it. Then the rated voltage. I think this voltage is automatically selected. So at this secondary side we now have 11 kV. So the the voltage rating of this breaker will be 11 kV, and we do not have 11 kV here. We have 15, so you are going to select 15. So then the rated amps is let's select 1250 here. So you click on OK. Then you select the circuit breaker, the other circuit breakers. Then all of them are in 11 kV. So you select 15, 1250, then click on OK. There are other features that you can actually do on the breaker settings, but for now let's try to maintain these ones that we actually need for this video. So 15 rated amps, 1250. Click on OK. Yeah, so we've been able to modify all the system parameters. So 33 kV bus, the power transformer, the cable, the size of the 11 kV breaker, the size of the conductor, the bus size, and the load. So I think we've been able to achieve that in this video. Before the next video, keep learning, keep watching.